Good morning. We'll start our section of solids chapter. Today we shall take a problem on a tetrahedron. So what is a tetrahedron? A tetrahedron is a one which will be having four equilateral triangles. So a tetrahedron of sides 60 mm is resting on the HP. The tetrahedron is resting on HP on its sides. One of its faces. It is resting on one of its faces with an edge perpendicular to VP. So the tetrahedron which is resting on one of its face on HP will be having an edge perpendicular to VP and nearest base corner is 25 mm in front of width. So whenever we draw the tetrahedron in the top view, we should be aware that we draw the nearest base corner at a distance of 25 mm from the XY plane. Full stop. A vertical trace whose angle of inclination is 55 degree with the reference line XY cuts the solid by passing through the axis at a height of 40 mm above the base. So he says that whenever you draw the vertical trace, its inclination is 55 degree and it is supposed to be drawn at a height of 40 mm above the base. Full stop. Draw the resulting sectional view and true shape of section. So we need to obtain the sectional view and the true shape of section. Full stop. Let us start with the solution now. Just draw the tetrahedron. So I have just drawn the XY line, write VP and HP. Draw the tetrahedron measuring 60 mm sides, and he has given in the statement that whenever it is drawn, the tetrahedron will be having one of its edge perpendicular to VP. So that's why I have satisfied the condition by taking this edge of the tetrahedron as perpendicular to our VP. Now this tetrahedron measures 60 mm as you know, and this edge or the corner which is nearer to this XY line should be at a distance of 25 mm from XY plane. So before you draw the tetrahedron, be aware that it is kept at a distance of 25 mm. So now I have drawn a tetrahedron. So let me name the tetrahedron first. So name it A, B and C. So you can see that base is one triangle, this is one triangle, the second, third and fourth. So four triangles, so it's a tetrahedron. Let me draw its front view and obtain the front view. Right, I have drawn the front view of the tetrahedron. So what is the height of the tetrahedron? So it will be 60 mm. So measuring from its center, so this line, project the center where you get in the top view. How do you get the center O? Just by tracing the midpoints of all the sides, join them, so you get the median. So where all the three medians intersect, so that point will be the center. So from this center O, drop a vertical line till the XY line and measure a height of 60 mm, which is the height of your tetrahedron. Then join the sides A, O and CO. So now we'll name the vertex in the front view. So this is A dash, B dash. A dash is nearer to the XY line, so therefore it is in bracket. B dash and this is C dash. Now let me move to the second statement of the problem. In the second statement he has said that the vertical trace is nothing but an angle of inclination of 55 degree with the reference plane, and this is cut at a height of 40 mm above the base. So therefore from the base, that means from the base of the front view, you measure a height of 40 mm. See here, measure a height of 40 mm. I am taking with my ref scale a height of 40 mm, and this is the point where it is 40 mm. So draw just a line, horizontal line, such that it will cut the axis at a point. This is my point. Place your protractor and measure an inclination of 55 degree. So I will place my protractor just here and measure 55 degrees. So this is 55 degree I have measured, and join this 55 degree line in such a way that it will bisect your triangle in the front view and extend it so that you can measure its inclination till your xy line, wherever this meets the xy line, until that point you extend it, so that it will be able for you to measure the inclination. So this becomes my section plane. So let me call this as S and S. So the direction of the cutting of the section plane is drawn just by showing the arrowheads. Show the arrowheads like this. So these are the arrowheads. I'll just show the arrow symbol, and so this is the arrow symbol I have shown. So, and this is the section plane. So you need to draw the resulting sectional view. So this angle is how much? 55 degree. So this is 55 degree, and I have drawn this at a height of 40 mm. So I will show the dimension also. So this is 40 mm. So this I have drawn at a height of 40 mm. Now complete the true shape of the section. So to draw the true shape of section, what we need to do, we should see where the section plane has cut. So this point, it is 1 where it has been cutting. So this point I shall name it as 1 and 2. This one as 2 and this one as 3. So 1, 2 and 3. So this is 1 dash, 2 dash and 3 dash. So let me keep here 3 dash in the bracket. Right. Now to draw the x2 y2 line, they should be drawn perpendicular. So therefore, where we should draw the perpendicular lines? So we shall draw the perpendicular lines from these 2 points. So place your protractor and measure 90 degrees. So I will just take 90 degree from the point 2, and even from point 1 I will take 90 degrees. I will just show 90 degree, and I will draw the lines perpendicular to these sectional points. Right. Now we should obtain the line x2 y2. So always the x2 y2 line is always parallel to the sectional plane. So just draw a line x2 y2, name it as x2 and y2. As usual, you try to measure the distances where these points 2 and 1 are measuring. So trace back these points again to your top view. See here, draw vertical lines again from 2 dash, so that it will intersect in the top view at a point. So this point, it is dropped from 2 dash, so therefore it is named as 2. Let me drop a vertical from this point 1. So I will just drop a line from vertical line from 1. So it intersects AO. Let me call this as 1. So the same line has to be extended. So further, so to get the point 3. Now this 1, 2 and 3 are nothing but these are the sectional top view. So join these points, 3 points in the top view to obtain a triangle which will help you to get the sectional top view of the triangle. How to indicate that this is a sectional top view? Just hatch it by 45 degree lines. So just hatch it by 45 degree lines, keeping a spacing of 2 to 3 mm. So this will be your sectional top view. Right. Now to complete the one more step, last step of the problem, you need to find out the true shape of section. So true shape of section, as I said in my previous problems also. So from this point 1, see, go on checking where the point meets the xy line. So this is the point where it meets. So keeping your compass on this point, measure the distance from point 1 to the point and place it on the x2 y2 line and cut the arc. So this point will become your 1 suffix 1. Similarly, the same point I will measure 1 and 3, and I will keep it on the same point and measure and cut an arc. So since I have my line need to be extended, I am just extending this. See here. So this arc has to be extended. So it will meet at the point 3 suffix 1. Another line, this is parallel line, I will just extend that also because maybe my arc may not be able to cut it. So just I will extend it. Now measure the distance 2. So this is the point from 2. Why? Because this line is been drawn from the point 2 dash. So this is coming here. So measure this distance to the point 2. So keeping this on the line perpendicular drawn from point 2, I will cut an arc so that I will get the point 2 suffix 1. Now I will join all these points 1, 2 and 3 and hatch them. Okay, so just see here, join this 1 and 2, 1 and 3, and similarly I will join 2 and 3. So this will be my true shape of section. So hatch it. I am just hatching it by 45-degree lines. So this will be the true shape of section. The true shape of section is also a triangle. So just show that this is the true shape of section. So I hope you don't have any doubts now. So this completes the solution of the problem. Thank you.